This is concept exam number 9. This is concept 11. First question is just what's the vertex of the function? I can't see the vertex in this form, so I'm going to try to rewrite this in a different form. What I'd like to do is factor a 2 out of this, absolute value. Gets me down to here. Now I can see the vertex. The vertex is going to be negative 3, 2. Remember, the x-coordinate comes from the opposite of this value when I have a 1x, a positive 1x here, and the y-coordinate comes from the value there on the end. So my vertex is at negative 3, 2. Any questions here? Okay, this next problem asks me to write two linear equations I could use to graph the given absolute value here. Well, one of them is just drop the absolute values. So y equals negative 3x plus 8. And the other one is change all the signs on this right side. So instead of a negative 3x, I have a positive 3x. Instead of a positive 8, I have a negative 8. So there's my two equations I could use to help me graph that absolute value. Any questions here? Concept 12, they want me to graph this absolute value. I can see that that thing's going to open down because the negative, and I've got to shift 6 to the right. So I'm going to choose to put my y-axis over here so I have room to shift to the right. My x-axis right here. So my vertex I can see is going to be at 6, 0. 6 because it's always the opposite of what I'm looking at here for the x. Plus, there's like a plus 0 here, so I know it's going to be 0 off the x-axis up or down. So I'm going to go 6 to the right. 1, 2, 3, 4, 5, 6. There's my vertex point. I'm going to open down with the sides that have slopes of 1 or negative 1. Go down 1 over 1, that'll give me that slope of 1. And then down 1 over 1 gives me that steepness of 1 on this side also. And I can go ahead then and draw my absolute value. Any questions here? Okay, concept 13, we're asked to solve a linear system using substitution and or elimination. On number 4, I'm just going to choose elimination. I see if I add the equations, the x's will zero out or eliminate. The 1y minus plus a negative 4y gives me a negative 3y. If I add the 2 and the negative 14, I get negative 12. Dividing both sides by negative 3 gives me y equals 4. Now I'm going to take that value and substitute it into one of the original equations. So negative x plus y, instead of y I'm going to go and put the 4 in, equals 2. Subtract that 4 from both sides. Negative x equals negative 2 divided by negative 1 and x equals 2. So it looks like my solution is 2, 4, but I'm going to check that by inserting that into the second equation. I put a 2 in for x, I have 2 minus, put a 4 in for y. 4 times 4 is 16. 2 minus 16 does equal negative 14, so that solution is correct and can't be wrong. Any questions here? We've got, I'm going to choose to do elimination. But I think I'm going to multiply, let's see, the top equation by 5, and the bottom equation by 6, and so I can eliminate the x's. So the top equation by 5 gives me a 30x plus a 25y equals a 35. Don't forget to go clear to both sides here. The bottom equation by 6 gives me 30x minus 36y equals 96. If I subtract these equations, I'll get something I can work with. 30x minus 30x is 0, that's a good thing. 25y minus a negative 36y is a 61y equals 35 minus 96 is a negative 61. So when we divide both sides by 61, we get y as negative 1. Let's take that value for negative 1, put it back in the first equation to see what x is. So 6 times x plus 5 times y, which is negative 1, equals 7. 6x minus 5 equals 7. Add the 5 to both sides. 6x equals 12, and divide by 6x equals 2. So it looks like the solution is 2, negative 1. Let's check that in the second equation. 5 times 2 is 10. Negative 6 times negative 1 is positive 6. 10 and positive 6 is 16. So this solution is correct and can't be wrong. Any questions? Okay, number 6, concept 14, they just want us to graph the system of inequalities. So numbers are looking pretty small. It looks like you could probably just put my x and y axis right here in the middle. first equation has a y-intercept of 3, 1, 2, 3, and a slope of negative 3, so I'll fall 3, 1, 2, 3, and run 1. Do that again, 1, 2, 3, and run 1. And I should be able to draw a line through there. This is a solid line because it is or equal. Draw a line through there. Which side am I shading? Well, let's see, if I try 0, 0, a test point, I get 0 is less than 3, that's true. So we're going to be shading the lower side here. And then the other equation has a y-intercept at 2 and a slope of positive 3. So I'm going to rise 3, 1, 2, 3, and run 1. And let's just repeat that in the reverse direction here. So I have a few points to look at. This is not or equal, so this has to be a dashed line. So I'll dash a line through there. And then check for shading. If I try 0, 0 here, 0 is greater than 2 is false. So it's going to be on the above side of that line. And shading overlap would be in this region here. And you just shade that in. Remember, only shade when you've got a reason to, and the greater than, less than inequalities give us a reason to. Any questions here? Okay, number 7, an exam consists of 2 parts, section X and a section Y. There can be a maximum of 85 questions on the exam. There must be at least 5 more questions on Y than on X. Write a system of inequalities. So this is what I have to do before I'm done. Write a system of inequalities to model the number of questions and graph the system. So let's see what we've got. We'll just go ahead and let X be the number in section X and Y be the number of questions in section Y. If there can be a maximum of 85, we should be able to say X plus Y can be no bigger than or less than or equal to 85. This one about at least 5 more in X than Y is a little tricky. So let's set up Y and X. There's more in Y than X. So if I want these to be balanced, I would have to put 5 more into X so they'd be balanced because there's already 5 more in Y. But I don't really want them to be balanced. I want Y to be at least that much bigger than X, so that's greater than or equal to. And then we would have, can't have a negative number of questions, so X is greater than or equal to 0, and Y is greater than or equal to 0. So there's one chunk of what I was asked to do. One part is to find the inequalities. We've got that. Now we need to go ahead and graph. See, looking at these values, since X is greater than or equal to 0 and Y is greater than or equal to 0 forces us into the first quadrant, I'm just going to let these edges be my X and Y's. I've got some pretty large values here in 85, so I'll allow my scale to go by 10, so we have 10, 20, 30, 40, 50, 100 on the edge here, and this would be also by 10s, 20, 30, 40, 50, and 100 at the top edge. This first equation, if X is 0, Y is 85, so here's 100, 90, 80, and 5. Same thing, if Y is 0, X is 85, 190, 80, and 5. That's a solid line because of the or equal, so we can go ahead and sketch that in. And if we test 0, 0, it would be true, so we'd be shading the low, the 0, 0 side of the line. The other one, a little more interesting. If X is 0, Y would be 5 for that to be equal. If we let Y equal 0, then X would have to be negative 5, but X is supposed to be greater than 0. So let's try something different. Let's say if X is 30, what's Y? If I put a 30 in here, Y would equal 30 plus 5 or 35. So let's plot those 2 points. I've got 0, 5, about right here, and 30, 35, 10, 20, 30, 10, 20, 35, about right here. And go ahead and sketch that line. And then look for shading. Let's see, 0, 0, 0 is greater than 5 is false. So we want to shade opposite the 0, 0 side, which would be up here. And then the shading would overlap in this region, this triangular region here. That's all we were asked to do. We weren't asked to take that any farther, so we'll stop right there. Any questions? Okay, this is probably the biggest problem on the exam, the one that takes the most time. So let's see if we can get through here. We've got, we're supposed to take this system of constraints and name all the vertices and find the maximum value. So let's see, we're restricted to the first quadrant by these two constraints. I'm going to go ahead and divide a 2 out of everything here to make this smaller, 3x minus y is less than or equal to 6. And let's divide a 4 out of everything here to make this smaller, y is less than or equal to x plus 2. Since I'm restricted to the first quadrant by the first two constraints, let's go ahead and just work in the first quadrant here. The first equation, let's see, if x is 0, y would have to be negative 6. Those are not first quadrant points. If y is 0, x would be 2. That'll work. 2, 0. I can plot that point. Let's try something else that might work fairly easy. Let's see, if x is 3, then y would have to be 3 because 9 minus 3 is 6. That'll work. So 3, 3, 3, 3. Let's go ahead and plot that line. Okay, let's check for shading here. If I plug in 0, 0, 0 is less than 6 is true, so I'm going to shade the 0, 0 or the true side here. And let's go do the other equation. Well, let's just graph the other equation using the intercept. So it says the intercept is at 2, 1, 2, and it has a slope of 1, so rise 1, run 1, rise 1, run 1. Let's go ahead and draw that line. Here we go. If we check for shading, put in 0, 0, 0 is less than 2 is true, so we're going to shade the true side, the 0, 0 side. That means the overlap is in this region, this side here. Okay, so we've got the region, now we just got to find the vertices. We've got the 0, 0, we've got the 0, 2, and we've got the 2, 0. We need to find this one. It sure looks like it's 1, that's 2, 3, 4, over 4 and up 6. Let's test that. If I put in 4, 6, 12 minus 6 is 6, that works. If I put in 4, 4 plus 2 is 6, that works. So that is 4, 6. It's kind of nice when they come out that nice. And we've got to now check for a maximum. My cost function is 4x minus 3y. I don't know why I want to maximize cost, so let's just call it a C function. 0, 0, 0, 2, 4, 6, and 2, 0. Let's see, 0, 0 substituted in for x and y gives me 0, 0, 2 gives me a negative 6, 4, 6 gives me a negative 4, and 2, 0 gives me an 8. Our max, the only thing they asked us for was find the max. Our max is 8. And we are done. We found all the vertices. That was the first part they asked us to do, and then find the maximum value, which in this case is 8. Any questions?